continuing on with similarity, what we're going to work on this lesson is the criteria to prove that two triangles are similar. And we'll begin here with the angle-angle similarity. That's angle-angle similarity. And remember that for similar polygons that we discussed, that the angle measurements remain the same, but the sides changed by a certain proportion or scale. And what happens here is thinking about triangles and angle-angle. Well, let's just tackle the two. It says two angles of one triangle are congruent to two. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So that two angles is enough. But remember before when we talked about the interior angle sum, and we said when it came to triangles that if two angles of one triangle were congruent to two angles of another triangle, then we knew that the third angle had to be the same. So that's why we only require two angle similarity, because the third angle is, we can prove, is also congruent. So looking at this, this is one of the common things that we see. It says determine whether the triangles are similar. And if you notice, I have two triangles basically sitting on top of each other. And when you have this, it's oftentimes easiest to separate the two. So looking at this, I have this triangle, which would be Q, so the smaller triangle. And then I have the larger triangle. I know these are not drawn very well, but. And then we know that this is parallel to this. And we share an angle, right? We know that those two angles are congruent. And what do we know about two parallel lines cut by transversal? That right here, these two parallel lines cut by transversal, we know either K is congruent to Q here, K and Q would be congruent, or I could also say that P and J are congruent. So it just depends on which way you approach that. I know, again, that those two angles are congruent, or I could have turned around and said, well, I know that those two angles are congruent. So separating them makes it a little bit easier to see. And then here, determining whether these two triangles are similar. Well, I have one angle measurement that is the same, but do I have two angle measurements? Well, if this is 47, this is 44. Well, those don't match up, but what are my other two angle measurements? This would be, it should be 90 minus 44, which is going to be 46 degrees. Okay, and then this one would have been 90 minus 47, which is 43 degrees. So no, they actually are not congruent, or not similar triangles, because the angle measurements do not, they only have one angle that is congruent. So there we go. Looking here for using parts of similar triangles. Okay, it says DeMarco is teaching Tay, I guess, how to play handball. Tay prefers to return the ball on the serve when balanced to a height of 42 inches. When DeMarco serves the ball, where should he aim for the ball to hit the front wall to ensure that it bounces at the short line and up to Tay standing 11 feet behind the short line? Assume that the angles formed by the path of the bouncing ball are congruent. So just looking at this image, we have, this is the height, right? Let's see here, DeMarco is teaching, right? DeMarco serves the ball where he should aim, bounce to a height of 42 inches, right? Bounces to a height of 42 inches. And then Tay is standing 11 feet away from the short line. And then assume when DeMarco serves the ball, what should he aim the ball to hit the front wall at to ensure that it bounces at the short line and up to Tay's stand or Tay's standing? So here looking at this triangle, it looks like I have, here's my 42 inches. I'm trying to hit to the 11 feet away at this triangle. Then this triangle over here is going to be 25, and I'm trying to figure out what that height is right there. So they have set it up as a proportion, right? They set it up as 11 over 25 is equal to 42 inches over some number, okay? And then they did some cross multiplying, and they've come up with the answer that the distance is going to be 11, or the height is going to be 7.95 feet. You could have set this up also as 11 over 42 is equal to 25 over some number. So the same thing applies. The ratio would give us the same quality here, the same quantity. So depending on if we compared one triangle to the other triangle, or they referenced the proportional sides. So just keep that in mind, that as long as you are consistent with your proportions, that you get the right answer. And when I say consistent, if we think of this as the small triangle and this is the large triangle, 11 is part of the small triangle, 42 inches is part of the small triangle, and that remains on top of my proportion. The large triangle remains on the bottom of my proportion. 25 feet is part of the large triangle, and X is part of the large triangle. Over here in this example, 11 and 42 are in the same proportion. 11 corresponds to 25 of the large. 42 corresponds to X on the large. So being consistent with setting up my proportions. Now the other two methods for similarity are going to be side, 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 and side, angle, side. So what that tells us is side, side, side. When we were talking about similar polygons, all three sides have to have the same scale factor. And again, the easiest, the same scale factor to show that they are similar. Versus if we have one angle, one included angle here, we only have to have two proportional sides. So it would be the sides on, you would have a side, an angle, the included angle, and another side, a side, the included angle, and another side. So those are the two other methods for determining similarity. So here, using side, 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 and side, angle, side, determine whether these triangles are similar. And we don't have any angles. They didn't give us any angle measurements, so we know we're looking at side, side, side. According to my name, right, determine whether these triangles are similar. How do I know without them giving me this similarity statement? How do I know which sides correspond to which? Well, the small sides correspond to the smallest side, the largest side corresponds to the largest side, and the middle side corresponds to the middle side. So what I mean by that is the shortest side of this triangle corresponds to the shortest side of this triangle. The longest side of this triangle corresponds to the longest side of this triangle. So JL corresponds to PQ. So we have 12 over 9 is 4/3. The shortest side, it's easier for me to skip there. 8 corresponds to 6. 8 over 6 is 4/3. And then the third side, let me back up a little bit there. I said JL corresponds to PQ. That is not true. JL corresponds to MQ, because those are the two medium length sides, the middle sides. And then the two longest sides would be 16 and 12, which is also 4/3. So since all of the scale factors are congruent, then we have side, side, side similarity. And then here, again, doing that determination, determine whether the triangles are similar. Explain your reasoning. Determining whether the triangles are similar. Well, I could probably identify the proportions here. I could identify this. Now, they didn't give me a third side. So what do I know? I know that these are vertical. Those two angles are vertical, so I could possibly have side angle side similarity, but I would have to identify the proportions, which the two smaller sides, I have this triangle, this is my smaller side, I have this triangle, this is my smaller side, so I have TW over YW, which is going to be 10 over 20, which is 1/2. And then I have ZW over WX, which is going to be 11 over 22, which is 1/2. So sure enough, I have the side angle side, the side angle side, and the proportions are the same. The scale factor is 1/2. So yeah, we do have triangle similarity for side angle side similarity. And let's see, what do we have here going on in this parts of similar triangles? Well, find the value of, oh my God, they got fractions in here. QN and PO, justify your answer. So show that these two triangles are similar. Well, in order to show that they are similar, what I do know is I have a smaller triangle, and then I have a large triangle, and I know, gosh, what else do I know? If, just thinking about it, if this triangle is they share angle M, and then if I have two parallel lines cut by a transversal, that makes this angle the same as this angle. So I have angle, which means I do have similarity in my triangles. And then I'm trying to find out this missing value here. And they have, let's see, what have they used in their example? They have used this side of my triangle and then this side of my triangle to find this missing value. So we know then, again, sometimes it's easier if we take and separate the triangles. And this is 5. M, P, O. And this is X plus, and I'm just going to go ahead and do that. And this entire length right here is 8. So that's how they came up with that. So they turned around and they said 8 over 5 is equal to X plus 2.25 over X. There you go. Then they went ahead and did the cross product property and distributed. And then as they simplified, they termed out that X is 3 3/4 or 3.75. And so that meant that this QN length was 3.75. So they were able to solve for the missing length by solving for X. So there you go. Looking at this example, understanding, let's see, find WR and RT. Well, the first thing you have to do is determine, do you have enough information? And I would say you do, because those two angles are congruent. So we do have angle similarity. Okay, what sides do we know are correspond? I know that 4RS corresponds to VR, because those are my two shortest sides. And then I would have X plus 6, because again, these two measurements are in the same triangle. So I kept them on top to these two measurements on bottom. And I would have 2X plus 6. And now I can do my cross product property and simplify. So with that, cross multiply I get 4 times 2x plus 6 is equal to 5 times x plus 6. And go ahead and combine like terms, do my inverse operations, and I found out that x is equal to 2. But it didn't ask me for the value of x, right? It asked me for the length of WR, so that would be 2 plus 6 is 8, and then 2 times 2 plus 6 is 10. So that would be the length of 10, and nope, I wrote it in the wrong spot. 8 and 10. So those are the lengths of the triangles, which would, since they're similar, we're able to find out that missing information. Now here, using this information, what can we come up with? And in this image, let's see, what do we have going on? It says Julia is designing an A-frame house. The entire house will be 40 feet tall, and the base of the house will be 60 feet long. Okay, 60 feet, 40 feet tall. She will build a second floor balcony along the front of the house. Great. The left side of the house will be 50 feet long. 50 feet long. And the balcony will intersect the side at 18.75 feet from the bottom. The peak of the house is directly above the midpoints of the base of the house, so this is a isosceles triangle. Calculate the total length of the balcony. So they have identified, what they've done is they've taken this and split it up into 2 triangles. Okay, and they said the length of this outer triangle is 50, the height is 40, and this entire thing is 60, so half of it would be 30. And then the smaller triangle here, they took 50 minus 18.75 and came up with this length would be 31.25. This length would be, let's see here, they're saying that it is total of 40 feet minus 15 would make it 25 feet. And then, of course, right here, this same length, we don't know, because that's what we're actually trying to figure out. So we could use the proportions, could use the Pythagorean theorem, but that would take a little bit longer and a little bit more effort. But what I find out is that by doing my proportions, that the scale factor of the sides, corresponding sides, turns out to be 1.6. So I do have a scale factor. I do have congruent angles and the consistent scale factor. And I know then that I'm able to use that information, since everything should have changed by the same scale factor. I know I have similar triangles. So they went ahead and 50 over 31.25 is equal to 30 over some number. Okay, that's what they did. Another option could have been that if I know that that is going to change by the scale factors, we could have manipulated the scale factors too. But in doing this, what they did is they said, hey, I'm going to cross multiply and then solve the equation, and it turns out the ED was going to be 18.75. That's only half of my balcony, so they went ahead and multiplied the balcony by 2, and multiplied that length by 2 to get the length of the balcony is 37.5 feet. And let's see here, we can do some quick thinking about this one. See here, Justin is playing tennis. He is serving, he stands 12 feet away from the net. Okay, so I'm just going to say I have the net. Okay. Okay, there you go. There's my tennis court. When serving, he stands 12 feet away. So he is right here, 12 feet away from the net, which is 3 feet tall. Okay. The ball is served from a height of 7.5 feet. So the ball tosses up in the air, and that height is going to be 7.5 feet, 7.5. Justin thinks the ball travels about 21.4 feet before it hits the ground 8 feet from the net. So this is 8 feet, hits the ground, and he thinks that it travels 21.4 feet before it hits the ground 8 feet away from the net. How far does the ball travel before it reaches the net? Oh, okay, so we want to calculate this distance, I guess. So looking at this, we have a little triangle that is 8 length, right, and 3 high. And then we have a larger triangle, which is the entire length of this larger triangle would be 20 and 7.5 and 21.4. And he wants to know how far does the ball travel before it reaches the net. We are trying to figure out, we would have to find this value and subtract it from 21.4, I think. Okay, so different ways to calculate this information. Of course, we do have angle similarity. I could say that in order to find this value, you can set your proportions up. I have x over 8 is proportional to 21.4 over 20. And cross multiplying, I get 20x is equal to this. So I'm able to cross multiply and simplify and find out that this value right here is 8.56. So if I am trying then to find out just how far does the ball travel before it hits the net, if the entire length is 21.4, I know this length is 8.56, I should be able to subtract it and say that, hey, 21.4 minus 8.56 is what? And that is using similarity to find out lengths in real-world applications. So that is how far the ball travels prior to hitting it.